Alright, so in today's video I'll be sharing with you this design, which is a table that is composed of a surface that is then contoured. Then we continue by creating all of the different details you see here. So I'll be going over all of the steps here. If you have any questions, let me know. This is perfect for those of you who want to learn about parametric design, creating furniture, fabrication. And so with that being said, thank you very much for being here, and let's jump right into the tutorial. All right, so the first thing we'll bring in is going to be a point. So let's go here to construct point. This will let us create a parametric point that is located here at 0, 0, 0. Then I'll route it through a point component. This will let me then change that location if I want to. So everything's going to be based off of this point. So from here, what we need to do is create the first geometry, which is going to be a circle. So we'll bring in a circle component. And so here we'll plug in the plane, and then for the radius, we can pick a number. So let's go here to 60.00. Now, for this design, a radius is not that useful because it's going to be twice as large. So this is going to be 120 overall. So let's decrease that to do a divide by 2. And this will let us use 60 as the diameter. So now what we need to do is take this point. So we're going to be creating like this toroidal kind of design. And so we need to take this point and move it up. So let's move it in the Z direction. So we'll use that point into the geometry. The motion is going to be in the Z direction. And then we'll use a slider once again. So let's go here to 12.00. And that will define the first movement of that point up, and then be able to create another circle right at that point. So we'll take this and we'll copy it over. So I'm sliding it, tapping Alt, and copying all of these components at the same time. This way I can use that point as a plane input. And now we can have two circles that are going to change in size depending on whatever size you pick for the slider. And also we can change the height of this. Now the next one, we're going to do the same thing as this, but we need to define it at the level where the top is going to be. So we'll take this, maybe clean it up a little bit here. Move this over, and then copy all of those one more time up. But this time, instead of 12, we're going to go to 32 or 34 for the top. So now we can change this from 60, let's say, to 24. This one to maybe a smaller number. And then this is going to be the top part, which is going to be the largest one. So we basically have 3 different circles. And now we're going to loft it together. So let's go here to, well, actually I'm going to take this one. So first let's loft it, and then I'll show you what I wanted to do. So let's go to loft between the first one. Then I'll hold down Shift to add another input to the next one. And then holding down Shift, the next one. Now, when you create a loft, there are different ways that you can define a loft. And you can right-click here in the options and see that there's a normal loft, loose, tight, and uniform. Depending on the look you're trying to go for, you might want to change those. The one that's defined right now is where the surface actually goes through all of those curves exactly. On loose, it actually uses it as a reference, and it doesn't necessarily touch it. So now with this, I will hide the input so it doesn't overlap with a lot of things. But what I wanted to show is that for the top, I actually want to be able to scale it in a particular direction. So I'll go to Scale, Non-Uniform. I'll bring in the circle into the geometry. The plane is going to be where the point is. That's the reference of where the plane is located. And the scale, let's say it's 1.5. Let's do a little bit more. 1.500 in the X direction. So I'll take the geometry and notice that all of these are already plugged in. And so I don't have to plug them in again. I can just double click here on the circle output. Double click here again, use this as the geometry. And since this is the one that goes into these curves and they're already defined and organized the way that they are, we can just override that to change the loft to the new scaled circle. So let's hide this input. And now we basically have, we can delete this relay now that we already have that, since we have the input hidden here. Now this is going to be the scale factor for the top. If we look at this here in elevation, we'll see that part of the surface goes a little bit above. So we can either change the loft options or just decrease the height of the second one to make sure that the surface doesn't go above the top line. And we can also hide this circle. Now we can also go back here to the first one and increase the size. So we just want to make sure that it's not smaller than the middle one, but that it could be larger than, or that it's not smaller than the center one, but it's larger than the center one, but smaller than the top one. Let's make it here at 30. Or maybe 36 is okay. And then here, we'll make this 72 for the top. Notice that we have created kind of a top here. Like I said, we don't want to have that surface go above that. So we can change this here, let's say to 24, and then play around with where we want that located. Okay, so now that we have that, let's now create the contours that are going to be arrayed vertically. So we'll take this loft option and we will use a command called contour to create contours from the bottom all the way to the top. So we'll go to this loft, plug that into the shape. The point is going to be the first point, which is the one down here, this one. And we'll take this and plug it into the point input. The direction is going to be in the Z direction. I'll show you at the end how you can change that and create different designs, but the idea is to create an array in the vertical direction, and the distance is going to be the size of your contours. So this is going to be 1.000. Let's do 2.0. And then change that back to, let's say, 1.5. And then hide the loft. Also hide all of these circles because now they're old as compared to the new contours, which define the same loft vertically. Now we can do the same thing in the X direction. So if you wanted to change that, we can create a custom vector or just use the XYZ vectors. And this will create another type of design. But for now, let's focus on the Z direction here. So if the contours are arrayed every 1.5 inches, well, we want to extrude all of these each by 1.5 inches. So this way we can stack them on top of each other. So let's go here to boundary surface, which to create a solid, we need to first turn these curves into a surface. So using boundary surfaces, we've created those surfaces, and now we can extrude these surfaces in the Z direction by 1.5. So I'm bringing in a unit Z using 1.5, the same slider for the distance as the input for the vector. And now this gets extruded up to create the overall design here. Now the only issue I see here is that there would be a lot of material wasted if you create contours that are solid going all the way up to the top. So one way to fix this is to so I'll disable this portion, bring back the contours, and instead of extruding it up as a solid, so using those surfaces, we're going to offset curve. So offset those contours to the inside, so in the negative direction. I'll use here 3.5. Let's do that again. 3.500 to have a little bit more precise input here. And then use a loft component, or use a boundary surface component to create a surface between those two. So between this one and this one. Now, the way that the contours here are organized is going to be different than the way that these contours are organized. So the way to make sure that the grafted set is compatible, you can copy this one and just go to distance of 0. So basically this is offset by 0, which keeps it the same. And this one's offset by 3.5, which makes sure that when you plug both of these in, we have the ability to stack them on top of each other and save on material here. Now notice that the top one, the one here at the top, is going to be, we need to offset it by more. So how do we fix this? Let me show you here. So if we look at all of these contours, we have an area that varies. So if we look at this through a panel, we'll see that as they get larger, that's where the offset needs to be bigger. And so the area increases, decreases, and then it increases again. So from the bottom, it's 1,000 square inches, and then at the top, it's about 6,000 square inches. So what we can do is use the area to create the offset. So we can use that here. We can use these contours. Those are the original ones. And then use the area and remap the numbers of the area. So we'll use the area as the input for the values. The source is going to be using bounds. Now bounds gives you the biggest and smallest number. So we'll go to area here. We actually need to flatten these areas so it's one entire set. The bounds means that the smallest and biggest number, the smallest is 263, the largest is 6593. And the target is going to be by how much we want to offset. So we go here to construct domain, and change the numbers here to 12.000, and use two sliders that vary between the smallest and largest number. And we can use that domain as the target. So what we've done is changed all those areas into smaller numbers that correspond to the size of it. And now we can use that map numbers. So what we're going to do now is disable those components, plug in these map numbers into the offset, which is negative because we want to offset it to the inside. And we need to graft it because we need to make sure that they're organized the same way that the offsets are. So now let's preview it again and see that now we've basically offset it more at the top, less in the middle, and a little bit more where it's necessary. So let's see here. Now let's go back to this and extrude it up using the same component we had before, but we will override it with these surfaces that we just created, which are these hollow rings. So it can be manufactured and also be able to overlap to be able to put it together. So now we'll go to here, we'll go to preview. So we'll go to middle click and enable. Now disable the preview on these. So now we can see it from the top that they all overlap. We have the minimum, which is 0, but we want to be able to have that as, let's say, like 4. And then where we need it to be a lot, it's going to be the maximum here. We just need them to overlap at least like an inch or two. And then the smaller ones can be, say, like 4 and then 12 here. I think that makes it pretty good. Now let's add some color so we can see exactly what's going on here. Sometimes when you have it with the regular preview, it's kind of difficult to see the design. Let's hide the wire display on this one. Hide the wire display on this one. Bring this up a little bit. Just keep it organized. Actually, we can just hide this one as well. Now let's use a custom preview. Use these as the output, so actually bring them through a geometry component. Plug them in and use a color swatch. We'll go here to 30 for orange. And then change the, let's see here. Lower the value here to like 50 to make it brown. And then use this as the input. Now let's change that brown for it to be a little bit darker, maybe even lighter. Let's just keep it orange here like this so you can see it nice and bright. And then hide the offsets and the lofts and the contours. Now we can change this back to a smaller number, like 1. Now the contours are going to be every 1 inch, and the height of each is going to be 1 inch. You can also go even smaller, like 0.5. And then here for the direction, now let's change that to the X direction. What happens here is, since we change it to the X direction, we don't have a closed surface with that. So you could change it to the length of each contour. So this doesn't work in something that's not closed. So we would actually have to take this loft and go to cap holes and then use the shape and change it. And now it works. But now it's still having some issues. So although you can create the contours in the X direction, you can't use the offset feature that we did for the vertical one on that. That is only necessary here because we need them to overlap in a specific way here. Now, the smaller the contours as well, you have a smaller gap here. So you could actually go here and decrease this number a lot more. So if we said 2, and then this number can get really small until here we see them overlap. Let's go to 4. So the more contours you have vertically, the smaller this number can be. And the less contours you have, so if they were every inch, well, that number needs to be higher because it needs to account for the fact that it's offset less. So now let's go back to this part, which is the top. And now I'm going to take this and extrude it up, and this is going to be a glass top. So the idea with this was to create a table that was based off of contours, and you can create a smooth form that can be subdivided and fabricated. So this tabletop can technically be fabricated if you cut each ring and glue it together, or have a way to fasten them together. And then here at the top, you can have this open, and then this top one be this. It's going to be a boundary surface. And then we can extrude this top. So extrude it in the Z direction. Now I'll just bring in a new slider here. So in the unit Z, and the height is going to be the height of the glass. So let's say it's a 1-inch glass here. Now we can use a different color for this. And then use the opacity portion of it to, let's say, make it 25 and hide this input. I'm not digging the color exactly here, so let's decrease that even more. Say 50%. We're saturation at 50, and then make sure that the glass here is 220. Now the cool thing about this design, so let's delete this, that's not necessary. The cool thing about this design is that we can change the size of the table using the initial sliders. So if we don't like this design, we can say make the center part maybe a little bit smaller. Let's go here to now 48. You can make the top larger. So if this is 72, we can go to 84. We can change the height of where that is located. So this is the top height. So it's 60 or 36 maybe at the top. And then this is going to be where that is located. Now, like I said earlier, we can also change the loft options to be loose, and this will make it less drastic, and use it as a reference here. Use where the curve is as a reference. So that may be desirable in some cases. The only important thing is to make sure that this ring always overlaps with the one below it. So we can decrease the size of this one maybe. But I actually feel like the loft options, I like it when it's either tight or normal. So let's make it on tight. Let's do that again. Notice that tight makes sure that it's exact, it goes to the exact point. So let's make this 24. Now this is going over the top, like we said, it shouldn't do. So let's decrease this to 12. Let's go back to our offset. Make sure that this is at a point where it overlaps. Notice that our top is now overlapping with our glass. So this is where we would either need to move the glass up. So if we want to extrude it up by 1 and the contours are 1, then we can just do 2. Move this up. So let's shift it. This can be a Z shift or a Z offset, and then use this as the input. Or if we put this at 0, we could go here to the output and go to call index, flatten the input, and then do -1, which means that it removes the last one. So here we can do -1 less than 0. So it either removes it or not. So this removes the last one because that's going to be glass. Let's also hide this. Or it doesn't, and then it overlaps. So now this is the final design here. I will have this available for you to download. If you have any questions, make sure to let me know. I just wanted to show you this idea that I had in mind, and I just wanted to work out the idea and share it with everyone. So thank you very much for being here. Hopefully you got something out of this, and I hope to see you in the next one.